everybody. I hope you guys are all doing well. We're going to look at a specific type of transformations. We are looking at dilations. Now, what this means is we are going to have what it says down here. I'm going to have some number multiplied in front of the function. So we've got three different parent functions. There are way more than these three types. So we're just going to look specifically at these ones. So if I multiply some number in front of my function, which I think we are most familiar with on linear functions, so I'm going to create a new function, g of x instead of f of x, but it is going to be multiplied by 3. It's the 3 times the x. So if I were to graph this, personally, I would do this like I would any other straight line. I put my y-intercept, and then I use my slope, in this case 3/1, to get another point. I can even put as many points as I want, but I keep that slope going and I get this straight line, which that's how most of us do with a linear function. But that does not really apply to these. There is no slope. I can't really just affect the slope. So what I can do is I can do like a stretch. So in this case, 3, the absolute value of 3 is greater than 1. So this kind of stretched it out. It like was dragging the end of the graph all the way up, and it was dragging the bottom of the graph all the way down. So it was kind of stretching it out. And it kind of did this with every point. It would take this point and it would drag it up. It was, in fact, going from a 1 up to a 3 because 1 times 3 is 3. So that's kind of how we got each of these. We just 0 times 3 is still 0, so that point stayed. So that's how this worked as far as a whole stretch goes. So let's see if we can apply that to another function. I'm going to make a g of x again, like a new function, and it's going to multiply by something greater than 1. So I'm going to multiply by maybe 2. So I've got a 2 times the x squared. So again, I'm in this first a is greater than 1. Absolute value of a is greater than 1. And the absolute value of 2 is 2. It is greater than 1. So I'm going to take each of these points and I'm going to stretch it out. I'm going to multiply by 2. So I'm looking at taking y values multiplied by 2. This y value is at 0, so 0 times 2 is still 0. Okay, so I'll plot that on the new graph. This point right here has a y value of 1, and 1 times 2 is 2. So my new y value is up to the 2. This y value is a 4, so I'm going to do 4 times 2 is 8. I still have the same x value. X value is 2, but my y value got stretched all the way up to the 8. So I got the point 2, 8. And you'll probably hear the word stretch a lot, kind of stretching this out. The same thing applies on the other side. This y value is 1, and 1 times 2 is 2. So I will go up to a y value of 2. This y value is 4 again, which 4 times 2 is 8. So that will get stretched up to the y value of 8. So here is the g of x function. Again, g of x is 2 times x squared. Okay, so this kind of, it stretched it out. It's hard to tell on the top one. You can see what it looks like down here though. It's like they took a hold of the end of this and kind of like pulled it up. They kind of stretched it out. Now let's look at what happens if your absolute value of a is less than 1. So something like a half, a 0.75, something you can take the absolute value of and it is less than 1. So let's look at doing a 0.5 times the absolute value of x, or 1/2 times the absolute value of x. So here's my new function, call it g of x again. So this, a lot of times people call it, instead of a stretch, they call it a shrink. So these y values are multiplied by 0.5, like you're taking a half of your y values. So it's kind of all shrinking down now. If there was anything down here, it would shrink up. It kind of all condenses. So again, my x values are going to stay the same. It's the y values that I'm going to multiply by half. 0 times a half is still 0. That has not changed. 1 times 1/2 is a half. All right, 2 times a half goes up to a 1. Okay, and you can do the same thing on the other side. Still a y value of 1. It's just multiplied by a half. So 1 times a half is 1/2. This 2y value, 2 times a half, is going to get me down to a 1. So here's kind of my new g of x function. And again, it's kind of went down into a half, into a 1. It's like it shrunk. It got like flattened out a bit. Okay, so the absolute value of a, if it is greater than 1, it will stretch your graph. And if the absolute value of a is less than 1, it will shrink your graph. These are called dilations. I hope that's helpful. Hope you guys are all having a good day, and hopefully I'll see you later.